Welcome everyone. In this video, we're going to solve this definite integral by using U-substitution. So we're going to let U to be sine theta. And you'll see why this is the choice because it will work out. And then the derivative of U respect to theta will be cosine theta d theta. So we're going to replace this right here with U. And this right here will be replaced with du, since we have everything that we wanted in the integral. So now we can rewrite the integral as follows. I can pull the 2 outside the integral. Then we have from negative pi over 2 to pi over 2 of cosine theta d theta over 1 plus sine theta squared. So now once we make the replacement, we also need to worry about this by changing the limit of integration. So we're going to change them as well. Since this limit of integration belongs to theta, we need to see what U be when theta is equal to negative pi over 2 and pi over 2. So let's go ahead and change them. Change the limit of integration. So when theta is equal to negative pi over 2, U is going to be sine of pi over 2. So I simply plug this in here. So that'll give me sine of negative pi over 2. That's going to be negative 1. So the limit of integration for U will be at negative 1. And then when theta is equal to pi over 2, which is the upper limit for theta, U is going to be sine of pi over 2, which is 1. So these are the new limit of integration if we go along with these substitutions. So now let's go ahead and rewrite the integral. So our integral is going to be 2 times the integral from negative 1 to 1 du over 1 plus u squared. And we know this is an inverse tangent, so you should also be familiar with that. This integral is tangent inverse of u. And we're going to take it from negative 1 to 1. Now we use the fundamental theorem of calculus to plug in the upper limit and then the lower limit. So this is 2 times tangent inverse of 1 minus 2 times tangent inverse of negative 1. And then we evaluate these. So this is equal to 2 times pi over 4, because that is tangent inverse of 1 is, minus 2 times tangent inverse of negative 1 is negative pi over 4. And then we simplify these answers algebraically. This is pi over 2 plus pi over 2. And that will simply give us 2 pi over 2, which is pi. So that's our answer to this integral.